Hi and welcome back to Rhinoceros and Grasshopper tutorials. I'm your host Saqib Aziz, and this is finally going to be the first segment of our Grasshopper tutorials. Now, the way that I wanted to do this is basically show you the new sets or new commands that we have in Grasshopper, and this is designed to be an intermediate course. And today we will look at the first command, which is going to be the twist that you can find in Transform, and we will look at how this twist command works. As you can see in the preview, I've already set up a geometry. We can then, of course, just basically learn how to set up the stripes, very simple stuff, and then look at this twist command that actually twists this geometry, and we want to learn how this logic actually works. We will also look at the graph mapper and understand how we can use this graph mapper to actually design our pattern that we want to draw upon to use as a twist mechanism. And we will have a look at some more features of this twist command, which is quite handy to know if you're working with it. So I hope you're excited, and let's start this tutorial right now. Okay, so basically let's start this tutorial, and I'm going to build it up from the beginning. So this is going to be basically my guidance, if you want, but I'm of course going to build it now from scratch. So I'm just going to disable that for a second. And this is an intermediate course, so I hope you are a little bit familiar with Grasshopper. If not, I'm also planning to do a beginner set. So let's get right to it. I'm gonna switch to shaded mode. And the first thing we want to draw is a point. So very basic stuff. We're just going to go to our tab here, to the vector tab, and then get our construct point method. And as you can see, I have now a preview in my Rhino viewport that is showing me that I've drawn this point. And I want to generate a secondary point to then derive at a line that we want to draw. Now, for this point, I want to give a kind of dimension in the y-axis, actually. So I'm just going to type in 20 with my slider. So double click on your canvas, type in 20, and that should bring up a number slider with that value already in store. And then I'm just going to put it here. And you can see that now I have a secondary point drawn on my canvas. And again, very simple. I'm going to use a line command, this one, not that one below, but that one, and just connect my start point, my A, which is the origin point in my Rhino canvas, and then the secondary point with an offset, let's say, in the Y coordinates. Now, this is a line, very simple. I'm going to hide these two, and a quick shortcut to actually do that is either you just select those items, press on your mouse wheel, and then hit this guy with the blindfold. That will disable the preview. You could also just use a short command, which I always use, is to say Control and Q. That will always bring or disable your preview. So Control and Q, and that's how you can disable geometry or components, so you don't have overload of information that you're actually looking at right now. Okay, so let's continue on. We have drawn this line, very good. Now we want to divide that line actually. And I'm just gonna double click on my canvas and type in divide. And of course, if you're somehow familiar with Rhino, you know, with Grasshopper, you know that there are different divide commands. You could divide it by length, by distance, but we want to use the simple divide mechanism, which is here. And I'm gonna just put in my line output L into the C, which is the curve. Don't be confused, it's a line, but it's also a curve, so that should work fine. And if you're wondering now why some of the components in Grasshopper have these two little, let's say, circular things cut in place, it's because that Grasshopper is currently working on a beta version of parallel computing, which is very handy. That just enables some of the components to right now actually distribute the workload or the computation better to your computer's memory. So if you just click on that with your right mouse button, you will see that it's actually telling you this component comes with parallel computing, and you can also, disable that, but I would say just always keep that, because that will actually compute much faster than the previous version. Okay, enough of that actually. Now we want to divide this curve, and as you know, the default setting of the divide, or of most commands that actually work in this sense, is, let's say, default value is 10. But of course, that's why we do Grasshopper. We want to make it dynamic and parametric. So what we want to do is actually supply a different slider. Now, I want to have a range between 0 and 40, just because that is the range that I was playing with. And if you type in 40, as few of you know, your range will always go to the next bigger number, which is in this case 100. So in order to have a range that actually goes from 0 to 40 and is not going to 100, I can just say 0 smaller than whatever value that I want, 40, press enter, and now the slider is set in such a way that actually the range is from 0 to 40. So I'm just going to hook it up to the end, n, and that is the number of segments, of course. And of course, you have the split segments at kinks. I don't have kinks, it's a straight line. So this is actually fine. And this simple mechanism just divides my input line in an equal unit or equal sized division, given the points that I have. Now, I have 40 right now, and I know that my line is 20, so I'm pretty sure that my line lengths are currently 0.5 units. I can also check that in a second, actually. So the next thing I want to do is actually generate those segments. So right now, these points are just points displayed on the curve. They don't actually do anything physical. So I want to use those points to actually divide the curve or shatter the curve. So that's the command we want to use now. We will say shatter. And again, quite simple. We just hook up our line, our curve that we want to actually shatter. And now we don't put in the points, but it was more efficient and clean if you put in the parameters of your shattering or your division points. So that means that this is calculated onto the line. The parameters, the parametric domain is calculated according to the line, and these will be used to actually divide or shatter your curves. Now, it is always useful to understand how this works because this component here actually gives you the t-values of your division. That works fine. But if you are actually shattering a curve and you do not have the t-values coming from a point, you always want to make sure that you reparameterize your curve if you're using values between 0 and 1. Now, that is maybe a topic for a different session, but always keep in mind that the shatter is quite sensitive to the length of your curve and the values that you supply. That means if my curve is 20 units long, as it is now, and I would supply this information basically coming as a text file, this could cause some problems. So just keep that in mind, but we will not dive into that too much. I'm just going to hide these 2 points now. Again, my shortcut, Control Q, and look at this here, and I have a list output with 20 line-like curves. Now, if I take my length command, I can just hook it up here and actually look at how my length are divided. So this will just calculate the curve that is inputted and give the length for that curve. I have 40 or more lines, segments, and those are all 0.5 in units. That is good. I can just delete that now. And I can just show you quickly that if you take the list item, so again, maybe that was too quick, list item, you can just hook up your list, in this case, the list of curves. And if I click on this and it's green, then you will see the first item because the index here is 0. If I would want to play with that, I could just say, let's say 0 smaller than 20, and then I could press on this and just hover along with my slider, and you can see I'll select each segment by its index. Just to give you an idea that these are actually really all shattered little lines now. So we have that actually. And now let's look what we actually want to do. So we want to use the twist command. Now the twist command again is a new command that you can see in the Grasshopper 6 and Rhino 6 included in where Grasshopper is included now. The twist command also is known, of course, in Rhino. You have that command also, and you can use it there. But if you want to find it now, you go to transform and you go to morph, and there are some new features like, let's say, flow. You have the maelstrom. And we want to look at our twist. Now let's just put the twist into our canvas and look what it actually wants from us. It wants, basically it has 3 informations that we can supply, but let's look at what is actually fundamental. So we want to supply a base geometry that will be twisted. That is going to be our surfaces, surface, whatever. And then we have a twist axis. So you can see that there's a line icon or line container actually. So that means that we have to have a geometry, and we also want to define an axis along which that geometry should be then twisted. And of course we have our angle. Now here I want to now already press on my mouse with my right mouse button and say that I want to work with degrees, right? Because if I don't do that, I will work in radians, and depending on your level or your knowledge, you can of course work with radians values, basically p values. You can divide a number by p and then supply it. And right now you can see we have 0.5 mile p times p, but I am more used to working with degrees. That is something that I understand better, and that's why I'm going to say degrees. And now the range is actually 0 to 360, which will be a full rotation if you want to do that. And 0, of course, will be no rotation. And of course, we have two other features, which we will look at in a second later, after we have actually done this twist. But I want to just quickly show that to you. So it's going to be infinite. That means that regardless of your axis, of the length of the axis, the twist will treat the twist axis as infinite. So the line will be recognized as a basic direction, but the twist itself will be applied to the surface, not only to the small line that you give it in, but to the entire, let's say, infinite axis of that. And rigid is something which we will also have here built in, and will be shown. Geometry will not be deformed as it is transformed. What that means is it's going to be not been twisted, but will be, in this case, just rotated. But I will show you that in a second. So we want to do the first thing, we want to supply the geometry, right? So we have our segments, and we can already extrude them and generate our first simple stripes. So that's what I'm going to do. I'm going to say extrude, and I'm going to hook up my segments here, and now I want to define my direction. So of course, if you're doing extrude methods, you want to always first put in your axis. This is going to be my z-axis, and by default this is already saying 1. So all my little segments are now extruded 1 unit up and generating these little stripes. But of course I want to control that dynamically, so I wanted to do that with another slider, but I thought to make it a little bit more interesting for you, I'm going to use a ratio instead. So I want to use a 16 to 9 ratio. So basically show you that, I'm just going to do it. And the nice thing is, if you double click on your canvas in Grasshopper, you can type in your ratio, let's say 16 divided 9, and the slider will always already give you the value, rounded to 3 digits. We can just do a simple multiplication, and we will get our height regarding our ratio that we defined. So right now we will have then 35 something z height. So I'm just going to supply that, and you can see now that we have our ratio set. Again, this is not mandatory for this example. I'm just going to go to my view that I have chosen for this, but I just wanted to show you that you can do that with your sliders and also work like in ratios and have that hooked up to your length in the z direction, for example. Okay, so now we have one step done. We can supply our basic shapes here. So we are one step closer. And now the next thing that we want to do is actually just hook up our angle, because that's quite straightforward. So I will again create here in our control panel, I will create a slider saying 0, smaller, 180. 180, of course, in this case, a full half rotation. And just gonna put in the slider into the designated input, which is the A with the degrees. And the nice thing about our sliders, of course, is that they will get the annotation automatically. So let's see if we can already do something. We can always check with our component. It's still orange, so it means that I click on this balloon and it will tell me, hey, you still need to supply something for X. Unless that, I can't really do, because I'm not understanding fully what you want from me. So let's just have this component and supply X now. Now X is going to be interesting, because here we want to actually bring in some more intelligence to it. We want to work with a graph mapper. But before we do that, I want to first show you the way that we want to do that. And the way that we want to do that is generating lines that go in the Z direction using our shattered segments here. And what I want to do is I want to create or get the midpoint of each of those segments. Yeah. And the way to do that is, of course, using our evaluate curve method. Evaluate curve, this guy with the T. I press enter. You put in the segments, your 14 segments here, and you put in a number. Okay. And the T value is usually between 0 and 1 if you reparameterize your curve. So if I hover over my C, I can press with my right mouse button. If I do not reparameterize my curve, then T value will always be the length that I give in, okay? If I do so, if I do click on this icon here, and I have my curves now here highlighted like so, the range is going to be between 0 and 1. So no matter what value I give in from 0 to 1, it will always be on that curve. And 0 is going to be the start point of the curve, and 1 is always going to be the same as the end point of the curve. If I don't do this, I really have to be careful what I put in T, because that's the length now. And if I don't know my length of my curve, and I say my curve is only 1 meter long, and I supply a value in T which is 2, and I do not have my curve highlighted like this, you will have a false command basically. Okay, so now that we actually did this, we went here and we said, okay, please, whatever comes inside as a curve, reparameterize it so that I can supply a value between 0 and 1. We can do that now. So I know that my start point is 0, my end point is 1, so my middle point must be therefore 0.5. And that's what I'm going to put in here. And now when we zoom in, you can see that it kind of looks perfectly right, yeah. And I could even just take a slider for a sense of demonstration and hook it up to this guy. And because of my curves, like we have done it parameterized, I can now see that 0 is the start point, and if I move along, I go to the end point of each of these one segments. So just to be on really the safe side here, I'm just going to highlight one of my curves, this guy, and you can see now this is the start point, this is the end point, and if I put in 0.5, this is the perfect middle point of that curve that I have just drawn there. Okay, that was a little bit longer than I expected, but I think that is good to know. If you are fairly new, this is quite helpful to understand. And the next thing that I want to actually use is the line SDL. Now, line SDL is basically a line that uses a start point as an input. That is going to be our midpoints now. And then it's going to use a direction. We don't really have to give a direction because as default value, it will always go up in Z. So you can see 0.01, which means X is 0, Y is 0, but X is facing upwards. And that is already perfect. Now we just have to give in a length. Now, if we would do this super straightforward, I could just supply my height here, which I have already calculated, put it in L, go back so you can actually see what I'm doing. Hide these two by shortcut Control Q, and then supply my lines into my X. And the component works. It's not complaining anymore, it's actually working. And I can now go to my angle here. I can go to my angle here and start actually rotating and twisting my stripes. So you can see what's happening is if I would zoom in a little bit more, you can see that actually these stripes are now being twisted along their axis, which is our lines here. So along these middle axis, those lines are being twisted, as you can see. So that is already good to know how to do that now with this twist function. But let's now do a little bit more interesting stuff, let's say. So I'm going to hide that for a second. And what I want to do now is actually bring in a graph mapper. Now, some of you might know this already. Some of you might be seeing this for the first time. So I'm going to try to explain it in a manner that both are satisfied. Graph mapper uses a graph that you can map numeric values to, which means that if I press on my graph mapper with my right mouse button, I can go to graph types, and then you see that you don't see me anymore, but you can see a list of different graphs that you can now draw upon. And I want to use the, let's say, the Bezier curve. And you can see that I have a Bezier now. And here, of course, I could go inside and change my X and Y values. But if you keep it as a default, it means that everything that I supply now will be remapped, let's say, into a language that is from 0 till 1. And that means that if I say I want a list, and you can see these handles here, you can of course adjust them. That's the whole clue of this Bezier curve. That means that my end length, for example, is 0 and my highest value is 1. And the highest value is right now at the end of this graph. I could of course bring it down, and then 1 is never met, basically. So this is how this somehow works, and I actually might do a whole tutorial on that because I think that needs more explaining. I agree, but let's see how it actually works with numeric values now. So let's say we have our segment, we have our points, right? We know that we have 14 points, and from those points we are drawing our lines. So we need maybe 40 different values if you want to do an interesting graph mapping, that is. So if I take my list length and hook up my P values inside this, I now have information that, okay, the list that you just gave me has 14 items in that, okay? And now I could use this actually to create a numeric, let's say, series, and that is what I'm going to actually type in, is series. And I want to tell him, hey, give me a series, please. As you can see, the series command has this option that you give a start value, you give a stepping, and you say how many of those steppings you want, and it will give you a list. In this case, it starts by 0. It has a stepping of 1 unit, and it has a count of 10. So it wants to create a series from 0, counting 10 times in 1 unit, which will result, of course, in a list that looks from 0 and goes till 9. Now I could use my L and say I want a list with 14 items. Yeah? And I can just put in a panel. Let me just type in panel. I can type that in here and just hook it up. And you can see that now I have a list with all the numeric values ranging from 0 till 39, sorry. Till 39, because of course 0 is counted as 1. It's a weird thing. You have to get used to it, that you're not counting starting with 1, but you're counting it starting with 0. And that means that your last value is not going to be 40, but 40 minus 1, which is 39. It's just something to get used to. Once you get used to it, you will be very comfortable with that. Okay, but now we have another problem though, because I was telling you, like before, my numeric range right now is from 0 till 1 for this graph mapper. That means every value that I've put in should be between 0 and 1, so it can get redistributed, or the values can be reordered to meet this graph actually. Yeah. So what that means is, if I show you that, there's this guy called Quick Graph. If you just hook it up, if I put my series there, you can see that the numeric values that I have supplied here right now is a linear graph, because I start with 0, I go up till 40, and it's a very linear motion, yeah, because the values are stepping always in 1, and that's how they are designed. It's a linear list. But what I want to derive at is actually that these values get somehow recalculated to meet the graph that looks like so. Looks like the Bezier curve. That's what I want to do. But right now I have a linear input. And what I want to do is actually I want to remap those values between a range from 0 to 1. Now we could use the remap, or we could use the power over 1 method right now. I'm going to show you the power over 1 because I think that's interesting also. Instead of doing remap, for this case we don't really need to do that because it's not that big of a deal. So I will type just over, and you can see that you get this component which is called 1 over, and that's what I want to get at. And what I want to do now is I want to take my 40 that I have here, put it into my 1 over, and I get a new value. Basically 1 over 40 is that value what I get here. And that is now what I want to supply into my number or my stepping. Now if I put that into my stepping, I will result in a different list. As you can see, my values have been recomputed in such a way that now I start at 0, but my stepping is 0.025, and I want 14 times to be iterated through that. So basically I have my starting at 1 is 0.025, then I have 0.05, etc. till I end up at a number which is 0.975. But very important, I actually want to get the last number to be 1 because that should be the highest value. The thing that I have to do now is simply put the over 1y into stepping. So my stepping starts at this value, not 0, but starts here. And then I get the last value to be 1. Now again, this is just a very quick demonstration. And depending on the task, you might want to work with the remap, which is much more, has much more control if you want. But I think it's interesting to know this alternative also. Okay, so now what we have done successfully, we have generated a list with 14 items ranging in the numeric domain from 0 till 1. And now we can just apply that to our graph mapper, and it will automatically change those values to meet this numeric graph. And we can see that if I just hook up a panel here. And if I hook up a panel here, you will see that the numbers have changed slightly, as you can see. But that just means that now the graph that the numbers that we supply are actually, if you put this graph mapper there, you can see now that the curve has changed. And what that means is that we can now simply, with the new inputs that we have here, put that into our L. But again, the last step that we have to understand, if we do that, we generate this Bezier line, as you can see here. It actually works, but it's only limited till 1 unit because we still have the highest length that we actually get out of here is our 1. In order to make that more interesting, of course, we want to have that over the whole length of our lines that we have before. So what we need to do as a last thing is to say multiply everything that we get out of this here by the height that we actually want to have, which is this ratio that we defined beforehand. I put it into A, and then I put it into my L here. And as you can see, these are now our lines that we want to use to actually draw our twist along, let's say. And the cool thing now is actually, after you have set this up, which might take a little longer than just to do it the normal way, the more straightforward way, is to actually now you can just be very free to play with that. As you can see here, your graph mapping is very up to you. You can play with those numeric domains in a visual and geometric manner. And you can also just go here, go to the graph types and change that like the way you want it to be. So you can change into parabol, you can go to conics, you can, I mean, there's no limit to that. The graph mappers that you have here, you can just explore. I liked the Bezier one because it's just a personal thing. So again, now that we have that, I will just quickly take all of this here and press or this time I'm going to use the mouse wheel, press on my mouse wheel and hit this blindfolded guy, and that will disable everything. And I can now hit this one and hit the not blindfolded guy, and he will actually show me the geometry. And we have actually successfully done our job already. As you can see, we have this strips that we defined earlier, and we have this curve graph mapper defining the way the twist has been added to it. And of course, we can now play with the values, or even just go to our graph mapper and start playing here and making this a little more interesting the way that we want it to be, and explore the potentials that we have there. So depending on your design task and if this is something that you might be interested in doing, this twist command could be done in such a way that you hook this up with more intelligence, of course. Now, before we continue on, I actually want to come back here and make this a little bit more clean. So we have 4 more or less sliders. 2 of them actually control something which we can see more dynamically. So if I go, I can now just see that this twist works very nicely, and of course I can limit the size of my panels and just have those twisted here, and then of course add more depth to it if I want. Of course I can also play with the ratio, I could play with the height, and etc. Now we can also do something that is very good to know. You can just reverse this input here. Now if I would do that, the whole graph would just be shifted or reversed, let's say. So I just take reverse list, and what that does, I have to show you here with 2 panels. If I put my list here and I hook up what I get from my graph mapper and what I get from my reversed list, now it is, the list itself is, like the name says, reversed. That means my first value here is not going to be 0-ish, but 1, which is here the last value. And the same is for here. The last value now is this value, which is in this list the first value. That means that the whole logic has been reversed, and that means if I hook this up, the graph will be reversed, right? So if you want to control that, if that is a design option for us and we want to control that, we want to use a stream filter. A stream filter is a quite useful tool. So let me bring that up. And it's not the stream gate, but it's a stream filter. And a stream filter enables you to put in, let's say, a multitude. You can also put some more if you want, just by zooming into it. But we have 2, so 2 is enough. I put in the first value, which is the normal list, and then in 1 I put the reversed list. And now I can control which one of these are been fed through to this guy by having a boolean from 0 to 1. So if I take a slider, for instance, I can also do that with a toggle, but I want to do it with a slider. I say 0, smaller 1, and now I hook this up at G, and this is my gate now. So I control with this the data stream of whatever I want, which 0 will be the normal list and 1 will be the reversed list. And I just put this up here, and you see now, you see nothing, nothing has changed. But if we go back to our master controller here, if I now flip the gate, the list has been reversed. And this is quite nice for you if this is a design option. If you say, hey, how does it look if it's reversed? This is something that you can, this is how you could do it. And in general, the stream filter tool is a very powerful tool that you should know as well. Okay, so we are almost there. I want to do a custom preview because the red illustration of my stripes is maybe not that nice. So I just put in my G into my geometry input here. I hide that, Control Q, and now I have a pinkish display, which is okay because I can now go to my Arctic view and actually have a much more nicer illustration of this. And actually the pink works quite well, to be honest, right now, but it's maybe not the color that you're aiming for, and that's what you can control with the M material. So we can just type in swatch, and that's a color swatch. You can just double click on it, on the color, and then you can just choose whatever color you want. If I hook up the white, it will be turned to white. Because of my background, white is maybe not the right color for me, so I can now go down the gray scale, let's say, and make that look a little bit more nice. And maybe this is too gray, so I can just click on that and just, play a little bit with that. And also what I want to do is I want to display the surface edges. So I'm just going to say I want to have a wireframe, and this will actually construct the borders of my individual stripes, give them me individually as lists. And you can see I have a quite nested list here, so I can just press on my V and say simplify. A simplify will then result in a cleaner list. and I can say join my curves. So I have one, or let's say continuous curves here. I can hide that now. So we have our lines here now. And what I want to use now is basically using a set of a human command. If you don't have human, please make sure to install it. It's quite handy, and they have this nice display tab here, and of course some other amazing stuff. But this display features a component which is called Custom Preview Line Weights. And what this enables you to do is actually put in the geometry, put in a swatch. Let's make it black or grayish and put it up in here, and then you will get the preview of that. For some reason, you can't get the same result using the normal Grasshopper preview. If I would show that to you, I put in this stuff here and here. I disable that, but I still don't see the lines at some point. I'm not sure if I am missing something or if this is something that can't be done right now, but the human command actually does that. So you can just see the outlines basically shown to you. And of course you can then change that just to hint the borders, let's say. Now this is, let's say, a setup that I am okay-ish with. And now I can continue on to show you some more features. So let's say we have our preview set, yeah, and we have some basic things set, so we can control again our curvature here, our flipping. Like I said, the last two things is actually these two guys here, so the infinite. And again, we can use, this time we will use a toggle, just to show you some different options. A toggle is nothing else than a slider from 0 till 1. That is a Boolean command, true, false, yes, no, 0, 1. So that's how you understand that. And this is something we can just now put in our eye, and I will just make a copy of that and put it into our rigid. Now, like I told you, the infinite will always treat the axis to be infinite. In this case, the axis that we have is our line SDL here. So instead of just taking this portion and twisting it only here, it will actually result in a more infinite twist, as I can do with the first one. And you will see that what it does now is interesting, maybe, if that is something you're looking for, is that after this twist is done, it will continue on twisting with the same kind of twist logic, because this is going infinite. It's not stopping here at this point, but it will always continue on. That's why we have the same results here, let's say. If you don't say that, if you say false, it will just limit it to that input that you have supplied. So that is interesting to know. Another interesting thing is if that twist that you say is going to be rigid or not. And how that looks is simply, if you toggle that, you will get a very, very strict twist, let's say. It's not even a twist anymore. It is just twisting along the axis without actually twisting the geometry. It's literally just rotating it now, but still in our function that we supplied into it. So that's interesting. It's not it's not rotating them all the same value, but it is rotating them taking into account the length that we have supplied here, the axis is, but it's just like one rotation. It's not a twist itself, which is quite handy if you're actually designing, let's say, facades and you don't want to do something crazy, but you want to do something which is still somehow buildable because it's just like normal panels just rotated, right? You can still perform a more complex, let's say, underlying logic to it, and resulting though in a very strict and buildable geometry, which is also again a quite nice feature that they included in this twist. So okay, there you go. What we did is actually quite good. We came through. So we have our, if I go back, we have our stripes. We just generated our stripes, very, very straightforward. Then we used our rotation and our twist command. We looked at how to use the graph mapper to actually generate some geometries, a different kind of logic, underlying logic to it. We looked at how to reverse those graphs just by reversing the numeric values. We looked at some more features of our twist command itself, and we looked at some very normal features also from the rigid value. So this is basically the end of the first segment of our Grasshopper tutorials covering the new components that are built in. So I hope you like this, and looking forward for the next video. And if you like this channel, please subscribe to it and give it a thumb up, and let's see you in the next one. Thank you very much.